I'm a little bit embarrassed. Um, and welcome to the advent of code. 2022. I'm Max. I'm a professional software developer. I am not a professional YouTube streamer, and therefore, um, the last 40 minutes has been streamed entirely to nobody. Um, which is not ideal, not a great start, but um, it's fine because what we're going to do is I'm going to talk over my solution to the first day of the advent of code, and tomorrow we will all make it live, and I'll remember to hit the go live button on the stream, because that would be good rather than talking to nobody for an hour. Yeah. Anyway, welcome to the advent of code. So Commie Duck says, ah ha 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 ha. Yes. Yeah, yeah, not great. It's fine. But it's fine. It means that I've done the code and I know it works, so I can now talk through how I would have done it or how I did do it. Anyway, so day one, Advent of Code. If you don't know what Advent of Code is, I'm just going to say everything I said first time round. This is practice. Advent of Code is a nice little programming challenge. We used to do programming challenges on here when I was previously streaming. They've all been hidden because that was my old streaming thing, and when I started doing magic stuff, I sort of went away from that, but they're all hidden. This is new. I wanted to do this year. We're going to try and get through the first 25 days. I want to see if I can actually finish it, and I thought people might want to see how I do it. I am a professional software developer. I've been doing this for I'm going to say 15 years now. 2022. Yeah, so about 15 years. My language of choice is going to be Rust. Rust is a newish. I say newish. It's like I've been working in Rust for 5 years now. It can't be that new. It is it's a language that is, it's got a little bit of rough edges, a few rough edges in terms of like learning it. But once you get into it, it's like the IDEs and stuff is just magical, and you can just it makes it so easy to code. Type-based coding is fantastic. Anyway, so day one, we have Santa's reindeer are regularly eating regular reindeer food, but they need a lot of magical energy to deliver presents on Christmas. For that, their favorite snack is a special type of star fruit. Wonderful. So we have to get 50. We're trying to get 50 stars by the December 25th. 2 stars a day, 2 per puzzle. So the puzzle today, the jungle is too overgrown and difficult to navigate. So elves are trying to go on an expedition, and each elf is carrying a bunch of food, and that amount of food is in a file. So the elves are writing down each of the items they've got, and each of the items have got calories. So we have, for this one, we have 1,000, 2,000, 3,000. That's one elf. 4,000, that's another elf. 5,000, 6,000, the third elf, fourth elf, and fifth elf. So that's the list. In case they get hungry and they need extra snacks, I relate, as I think everyone does. They want to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000 calories carried by the fourth elf. So find the elf carrying the most calories, and how many total calories is that elf carrying? My answer was this, but your answer will not be that. So let us go to our code. Hooray, here we are. So this is Rust. If you've never seen Rust before, this is it. This is Visual Studio because I really enjoy Visual Studio for doing Rust programming. The way that I'm going to structure this is have a library. My library is really straightforward. This is the one method I have in it so far. We will be adding to this over time. All of this code I will be pushing to the cmeister2/advent of code repository, which is my open source persona. yeah, I've many online personas. That is the original, and that is the online one. Yeah, so this is a utility function that we added to read lines. So we give it a path. The path is a file on disk. That path is opened. We are going to then read that out into an iterator, and a result says whether it succeeded or not. So in Rust, results are really awesome. If I mouse over this, Visual Studio will tell you what type this is. You can see this is pub type result. So it is a result that returns a T, which is just the thing that it's returning, or it returns an input output error. So a result is basically it's an either or. If it succeeds, it gives you the thing you want, and if it fails, it gives you an OK wrapped around the value, and if it fails, it gives you an error, and then it gives you tells you what the error is. And the way you bubble that up and consume those is one of the interesting things about Rust. But one of the nice things about it is this little question mark bubbles up errors. So when we have file open, that is a fallible thing that can happen. We have an input output result that can happen from that. If that fails, like we just want to pass that to the user. Like, you know, the file wasn't there. That's your fault. It's probably not accessible, or you gave me the wrong path, for example. Or it was like there's plenty of other things that can happen on Linux to say why a file can't be opened. But that gets propagated up. Otherwise, so yeah, the output of a file open is a file object. So we get the unwrapped file here, and then we are going to read from that file into a bunch of lines, and that gives us an iterator of actually gives us an iterator of results, which is a bit of a weird one. I might actually be updating this to like just return a thing of strings, because strings are quite easy to work with. In fact, let's do that now, because why not? And I can show you how easy, or I'll show you how nice it is to like refactor some Rust code. So the method that I was going for in my coding was opening up the step one input. So you can see that this gives us a lines buff reader file, which is just essentially just an iterator over the lines of the file. We get all the lines in the vector by mapping them. So we do lines.map, so it maps over an iterator. For each entry in that, we're going to have a line, and that line is a result, a string, or an error. I still haven't worked out exactly what errors can come from reading a line of a file, but whatever. And then just for testing purposes, we're going to just immediately unwrap that. That turns it into a string, and then we're going to collect them all together, and we're going to collect them into a vector of strings. So at the end of it, we have a big long array, essentially a vector. It's kind of like an array of strings. But that seems like quite a useful method, and I would rather have that than, say, a lines thing. So we're going to say let file iterator equals this. I'm going to paste this code down here. There we go. So that's the iterator that we want, and then we want to iterate over this and get the vectors out. In fact, we could probably just I'm just trying to think, if I do this, that's probably going to fail because it's not the right type. Also, that's going to fail because it's not called lines. Let's call it lines. That makes more sense. Just trying to think what happened if I do this. It probably shouts and goes, "You're doing the wrong thing." Oh yeah, because it's inside a mapping thing. It's fine. Line.unwrap is fine for the moment. There are other ways of like combining all these things together. Bolful says, "Oh, I thought I missed it." At the start of you can go back and watch the start of this. I have been streaming. I streamed to nobody for 40 minutes because I forgot to hit the go live button, because you don't have that on when I was streaming to Twitch. It was just like go live and it was fine. I was streaming but not live on YouTube. So yeah, it's entirely user error. So yeah, that's it's just my bad. So what we're going to do here is collect these lines together, and we're going to stick them inside this OK. And we're going to change the result types from lines buff reader blah 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 blah. We're going to call it a vec of strings instead. So instead, our function now has a useful thing. It returns a vector of strings, which are just lines essentially. So a string is just a literal string, UTF-8 encoded growable string, you know, like standard programming if you aware of that. A vector is a growable array type. Yeah, so unfortunately, what that has done now is broken our code, because suddenly this is not the right type. That's fine, because actually what we can do here is just do this, delete this line, and everything is hunky-dory once again. We're going to need to do exactly the same thing in step 2, because I copied and pasted code, because I am lazy. So split vector by blank line. So the way that I was going to process this is to split up the input array by the blank entries. Now there's a couple of ways you could do this. Sort of like the procedural method, I think, would be to go, you'd go through index by index, and it's like once you detect an empty line, you increment increment something like an index into an elf array, say, and it's like for each new just total it up is there. Rust is quite nice. Rust has got this split function that works on slices. Now slices are, so in vectors can be automatically converted into slices. They're trying to define a slice actually is quite interesting. I wonder if I can, don't think I can mouse over it. They're not growable bits. It's like a view into a vector, if that makes sense. So it's like a well, you can basically define a slice of a vector, say like look at the first 4 entries, for example, and it's like, oh yeah, okay, these immutable things are here. And so because slices have got a split method on them, which is this thing here, and vectors can automatically be converted into slices, you can call split on a vector. So let's just go back to what split actually does. It returns an iterator over subslices separated by elements that match pred, and the matched element is not contained in subslices. So if we look at the example, if you haven't seen, this is all coming from the Rust documentation. The Rust documentation is bloody fantastic. It's probably the best documented programming language I've ever worked with. And it's just fantastic. So yeah, this example. So we have an array of numbers 10, 40, 33, 20, and we're going to split by if the number is divisible by is it modulo 3? So is it divisible by 3? It's what we're saying here. So yeah, so 10 and 40 not, obviously 20 not, but 33 is. So it's going to return these first 2 elements and not this one. So for our purposes, we have an array at the moment that is string, and the lines in that string are either non-empty because they've got a number in them, or they're empty. So the way we're going to do that is say line.len equal to 0, and Clippy is telling us. So Clippy is it's a piece of software that sort of looks for your semantic issues and says you could do this code better. If we mouse over this, it says, hey, warning, Clippy len 0. If you use is empty, it's clearer and it's more explicit. So I'm like, quick fix. Okay, thank you, Clippy. Fix my code for me. Fantastic. So we're now saying, is our line empty? So is there nothing on the line? And then we're going to end up with what we're going to end up with is a vector of slices at that point, because we split them into sub slices. We're actually going to end up with a this collects an iterator into a collection, and this says we have a vector, so that's a big long list of smaller slices, and each of those smaller slices is basically that's an elf. That's all the things that the elf wrote down on their caloric values. And so what we're going to do about that, we're going to do some magic. So we have to work out which is the maximum elf. So we're going to say elves. So for each elf, we're going to iterate over each elf. So that means take each elf in turn, and we're going to look at that elf. And we're going to map. So we're going to say, what is that elf doing? Okay, so that elf is a that elf is a subslice of strings at this point. So it's basically a slice full of strings of like 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, but they're all string values, not number values. So what we need to do is convert those string values into number values. And the way we do that is to iterate over the subslices. We get a string value out. We're going to parse it as an unsigned 32-bit integer, which is probably big enough. And we're going to throw away the errors because it's probably fine. And if it errors, we could probably handle it. I mean, the production code probably would not like this. You've got to define your problem domains at some point. There are ways of professionally handling this, in that you can turn these into collections of if you turn these into result objects, you get a result U32 or a parseInt error. If you have an iterator of results, you can boil that into a single result object at the end of it, and that is the way that you tend to handle this. In fact, screw it, let's do it. Why not? What else are we going to do? Oh no, we shouldn't do that. The trouble is, I'm looking at what scope we are here. We're like nested within several things. It's going to be a little bit complicated, so it's fine. And I'm just explaining code at the moment anyway. So what we're saying here is, take those elves, map those values into strings, and at the end of it, we're going to end up with an iterator of numbers. So each of these things is an unsigned 32-bit number, got a bunch of numbers, and then we're just going to sum those values. Sum does exactly what you think it might do. We say caloric total is a U32 value, an unsigned 32 value. Now there could be overflows. If it's like max U32 value, that would be quite harsh on day one of the advent of code, so they're not going to do that. Our code is fine for now. So we say caloric total is U32, and then we return the caloric total. That's a U32 value. So we now have a value. We have an iterator. So the elves have been turned essentially into the total number of calories they control. And now we just want to find the maximum elf, essentially, because we have a number of totals and we need to find the maximum total. And we expect there to be value, otherwise there's no elves. And so when we run this test, going to shout at us, but it says the maximum caloric elf is 75,501 calories. Excellent, good, sorted. So back to the thing. By the time you calculate the answer, they might realize they've got a single point of failure, and that is the one big elf. And so what they want actually is the top 3 elves carrying the most calories, and how many calories are those elves carrying in total. So the way we're going to do that is we already have, at this point, we have a thing, a way of converting the elves into a set of totals. So this is our step 2. We've basically at the same point as step 1, but instead of going .max, we're going to turn that into, we're going to collect them as a vector of numbers. So we have a list of numbers at this point, and we want to work out the best way of taking the highest 3 values there. So the general way of doing that is sorting. You could iterate through them and sort of like have an ongoing tally of the top 3 values. Like there's various different ways of doing this, each of them with their own benefits, I would say. Generally speaking, I think sorting a list of numbers is, we're not talking about mission critical code here. Like if for some reason it made sense to do like an order 1 operation of like you have to just go through the thing once and tally up the top 3 values, otherwise bad things will happen, then we would probably not sort it. But for the moment, we're just going to sort our elves. And what that gives us, if we look at the sort unstable, if we have this array of numbers, when we sort unstable, we're gonna end up with an array sorted from the least to the most. Good. So we want the highest. We want the highest 3. And so we're going to say take the last 3 values. And the way we do that is to say iterate over our elves. We have a numeric list of elves. These are now sorted elves. We're going to reverse that iterator. That is a magical function. Usually iterators iterate from left to right. Yes. After using rev, an iterator will iterate from right to left. Now you can only do that if it has an end. And so, yeah, you have to have special double-ended iterators. But in our case, we do have that because we know that the list is finite. If it was an infinite list, we obviously wouldn't be able to do that. So we're going to reverse that iterator, and then we're going to say take 3. So it creates another iterator, which it just yields the first n elements. So it gives us the top 3 at that point. In reverse order. So it'll be like the highest, and then the next highest, and then the next highest, and then we're just going to sum those together. So we've basically taken all of these values, jumbled them together. But Rust is like, oh yeah, I know how to deal with that. That's good. And then we're going to cast that to a U32, or we're going to tell the compiler it's an unsigned 32 value, and then we're going to print it out. So we just go to our run test, and it gives us we have 215,594 calories in our top 3. And so we go and put that back into our thing, and it says, hooray, both parts of the puzzle are complete. They provide 2 gold stars. So that is how to solve day 1 of the 2022 Advent of Code. I've done it twice now. But yeah, that is how you do it. Over the next couple of days, over the next 25 days, trying to work out if this is specifically very explicitly written code, or if my brain is fried from using weird languages and can't grok imperative code. I'm just writing the code that comes to mind. This is how I'd write it at work, put it that way. Well, I say no one's ever going to ask me to write this at work, but yeah, certainly this is the sort of, this is the way I'm going about this. This is my development process. But yeah, one of the nice things about this language is it does allow you to quite quickly iterate over solutions, I would say. Not as much as Python. Python is a little bit easier in that aspect, but yeah, it's good times. Anyway, that is the end of today's stream. Tomorrow I will be back trying to do exactly the same thing for day 2, and this time I'll go live first time, so we don't screw up. And